Hello everyone, welcome back to this channel, and in today's video I'm going to show you how to solve this problem in kinematics. Let's look at the problem. So a rock is dropped from the top of a tall building, and after 3 seconds it hits the ground. So after 3 seconds this rock hits the ground, assuming no air resistance. How high is this building? So we have to find the height of this building. And we are also to take acceleration of free fall to be 9.8 meters per second squared. On the right here, we can see a building. So this is the tall building. And then we are to determine the height by simply dropping an object, in this case a rock. We dropped it and then took the time of 3 seconds to hit the ground. Now let's look at the solution. So to solve this problem, I'll first draw the building. So this is the building and this is the ground. With this, I have the rock that is dropped. And then we know that when this object is dropped, it is going to fall freely under the influence of gravitational pull. So now, there are some key important information in this problem that we need to take. So we have our rock here, which is dropped, meaning it wasn't given any initial speed. So it is simply the initial speed is equal to 0. And we know for motion with acceleration, in this case acceleration due to gravity, that is g minus 9.8 meters per second squared. It's minus because acceleration points downwards. Okay, this object or this rock here is going to speed up, falling down as it falls down until it hits the ground with some final velocity, v final, which we don't know. Now, we can place our origin over here such that this height traveled at the bottom here is going to be our h. In this case, if our origin is here, downwards it's going to be negative h. Now this is the problem setup, and we can take some few information from this setup that can help us to determine which kinematic equation of motion to use to solve this problem. Remember, a rock is dropped, giving it an initial speed of 0 because it is just dropped. It wasn't tossed, it was just dropped. It falls freely under gravitational pull, and the acceleration of gravity is 9.8 meters per second squared. That means because we do have acceleration, this object is going to speed up as it falls down until it hits the ground. And it took this whole motion 3 seconds for the object or the rock to hit the ground. Again, we are setting our origin at this point, and then going down, we have negative displacement, which is negative h. So in this case, the distance from the origin to the ground is going to be our h. So we can take this data from the problem. All right, so the data that we can take from this problem, the first one is going to be the initial velocity, vi equals 0, because we are told that object or the rock is dropped. and then it took a time of 3 seconds to hit the ground. Now, we are given g, that is acceleration of free fall. In this case, it's pointing downward, so it's going to be minus 9.8 meters per second squared. The final velocity, which we don't know, all right, and we know the initial position of this object, that is the origin, 0. And we know the final position of this object, which is minus h. And that is the h we are going to determine, because it will end up giving us that distance between the origin and the ground. Now, let's see, we have vi, we have time, we have g. We don't know the final velocity with which this object is going to hit the floor or the ground. So we leave it as it is. Now we have initial position, which is the origin, 0. We have the final position of this object, which is minus h. Okay. In this case, position is a vector or displacement. So it displaced from 0 downwards per our coordinate system, Cartesian coordinate system. Right. So if this is our x-axis, this is our y-axis. So if you go up, it's positive. Go down, it's negative. Go right, it's positive. Go left, it's negative. So now let's solve the problem. The best kinematic equation we can use is delta y, because this is motion with acceleration, with constant acceleration. So we have delta y, which is the displacement, the vertical displacement as this rock falls down, is equal to 1/2 times the acceleration of free fall times the time squared plus the initial speed times time. But delta y here is just y final minus y initial. And that is equal to 1/2 gt squared plus vit. Now, because the object was dropped, as we've seen in the initial analysis here, our vi is simply 0. So that sets this whole term here, to 0. So with this, we can say the y final, which is minus h, minus y initial, which is 0, because that is the origin, is equal to 1/2 times minus g, so g is negative, times t squared. All right, so we can have minus h equals minus 1/2 g t squared. And the negatives will cancel out, leaving h, which is the final position of the object or displacement of the object from the origin, equals 1/2 g t squared. So if we substitute, we have 1/2 times 9.8 times t, which is 3 squared. And evaluating this is going to give us the height equals 44.1 meters. Therefore, after solving this problem, which is an object that is dropped, knowing the time it took this object to hit the ground, knowing acceleration of free fall, the height the height of this building, that's the height it traveled until it hit the floor from the top of the building, is equal to 44 0.1 meters. And this is the same as the height of this building. So yeah, this is a very simple and straightforward problem or experiment we can use to determine the height of buildings by simply dropping an object from the top of the building and then timing how long it takes the object to hit the ground. Alright, if you enjoyed this video or it was in any way helpful, please subscribe, like and share. And until then, I'm going to see you in my next video. Thank you.